So the one starts with gametogenesis. So your first question should be, what is gametogenesis? What is gametogenesis? Formation of gametes in the gonad is also called gametogenesis. Gametogenesis is the formation of gametes in the gonad. So before we dive into gametogenesis, I want you to understand the cell cycle. So I want to start with the cell cycle so that when I'm talking about mitotic and meiotic cell division, you will have an understanding of what you're talking about. So first, let's start with mitotic cell division, which is also called mitosis. So what happens to the mitotic? In the mitotic cell division, the parent cell have 46 chromosomes and they will divide. When they divide, they will form two daughter cells, and these two daughter cells also have 46 chromosomes. So the implication is, in mitotic cell division, the resulting daughter cells have the same number of chromosomes as the parent cell that produces them, and the parent cell have two N. Two N means haploid and one N means diploid. Therefore, the two daughter cell we have what? Two N. Just have it in mind, in mitotic cell division, the daughter cell have the same number of chromosomes as the parent cell that produces them, and it is 46 chromosome, which is a diploid. While in meiosis, we have two phases of meiosis. We have meiosis 1 and we have meiosis 2. So what happens and what is meiosis? In meiosis, the resulting daughter cell have half number of chromosome as the parent cell that's produced them. The parent cell have half number of chromosome as the parent cell that produces them. The implication is, in meiotic cell division, the resulting daughter cells, the end product of meiotic cell division, will give us half number of chromosome, and half number of chromosome is 23 chromosome, which is N, while diploid is 2N, and they have what? 46 chromosome. Why in meiosis we have N, and we said we have first mitotic meiotic cell division and second meiosis cell division. So in the first meiosis cell division, they divide in a way to reduce the chromosome from 46 to 23, while in the second meiotic cell division, they now divide in a way which is similar to the mitotic cell division. Remember, in the mitotic cell division, the resulting daughter cells have the same number of chromosomes as the parent cell. So this is also what is happening. As the parent cell undergo meiotic first cell division, what is now happen? This parent cell, which is diploid, is now converted to haploid, having 23 chromosomes. And they will now undergo another meiotic cell division, which is similar to the mitotic cell division, meaning that the chromosome will not reduce again, rather they will maintain that 23 chromosome, because mitotic cell division maintain the number of chromosomes as the parent cell that produces them. They were 23, and when they undergo second meiosis, and second meiosis is similar to mitotic cell division, so they will now form 23 daughter cell. So let's look at the features and composition of mitosis and meiosis. So purpose: why are we undergoing mitosis? Growth, repair and asexual reproduction. Remember, in reproduction you need mitotic cell division in order to form two daughter cells. Example, bacteria divides into two to form two daughter cells. Asexual reproduction. Asexual reproduction is a reproduction in which there is no fusion of gametes. It's just a parent cell dividing. So we have repair of tissues and we have growth. Example, in the formation of spermatid, or don't worry, we are going to talk all about those things. You just calm down and follow the playlist. You just use in growth. Example, during after zygote formation, the cell starts undergoing rapid mitotic cell division to start what? To start growing, to form 2 cells, 4 cells, 8 cells, 16 cells, then morula, to now blastocytes. So mitotic cell division, they undergo mitotic cell division. So meiosis in the other hand undergo sexual reproduction. So remember, a normal human being have 46 chromosomes, and for a normal human being to have 46 chromosomes mean that you are complete, you are good to go, you are complete. So during meiosis cell division, we now divide the cell to haploid. So we use them for sexual reproduction. Look at what I'm trying to do. During meiosis cell division, which we use for sexual reproduction, which two gametes are involved, where the sperm has to meet the egg. So what is happening? The sperm have undergo meiotic cell division to produce what we call spermatozoa. That process is called spermatogenesis. Don't worry, we are coming to all those things. Just what you have in mind is the process by which your your primordial germ cells or your cells produce sperm, or the process by which you produce sperm is a meiotic process, is a meiosis process. So the same thing, the process by which the female also produce egg is a meiosis process. So this results to sperm have half number of what? Chromosome. The egg have what? Half number of chromosome. What now happen? They will fuse together during fertilization. Fertilization is the process by which the male sperm meets the female egg. When they fuse together, they now form what we call zygote. That is fertilization. And what is happening? 23 chromosomes is coming from the female and 23 chromosomes is coming from the male. What's happening? They will now fuse together to form back 46 chromosomes. So they help in sexual reproduction. So the second thing there um is only one phase. Mitotic cell division is one phase. Now take a look at the good observation of this diagram. Mitotic cell division is what? One phase. It's just one process. While meiotic cell division is two. One, two, and three, four. Meaning, just look at this thing again. First, they just divide to give us two daughter cells. That's why we call it what? A one phase. And in meiosis, they divide first to form two daughter cells, which are haploid. Then they will now divide again, which is similar to mitotic cell division, to now form another what? Daughter cells. Next thing is two genetically identical. They are genetically identical. That is why bacteria from year to year, they are not changing. They are identical from year to year, they are not changing. Why? They are genetically unique, but they are changing. That is why you can never look like your father exactly or your mother exactly. You have these two characters. You might look like your father and have some character of your mother. You might look like you might look like your parents, but you cannot look like one exactly. When you look like one exactly, then if they go to the recessive traits, you look like your mother. So in mitotic cell division, they are diploid. Diploid means they have 46 chromosome, which is 2n. And in meiosis, they are haploid. Haploid means they have 23 chromosomes. So let's go over to our main topic of the day, gametogenesis. Gametogenesis. What is gametogenesis? Medical students, let's go. Ngba. First, what is gametogenesis? Gametogenesis is the process by which we produce gametes from the what? From the gonad. We are producing gametes, we are specializing cells. And during gametogenesis, what is happening? We are converting a diploid cell having 46 chromosome to a haploid cell having 23 chromosome. From 46 chromosome to what? 23 chromosome. So let's go. Gametogenesis is the process of creating specialized haploid gametes from diploid germline cells. So gametogenesis is formation of haploid cells, haploid gametes from diploid. You know, gametes are sex cell that we use to produce zygotes. Sex cell example are your sperm and egg, they will fuse together to form zygote. This ensure the resulting offspring receive correct amount of genetic material, half from each parent. So when your mother produces egg, which is diploid, and your father produces sperm, which is diploid, you are going to have 80 something chromosome, which is abnormal. It is not possible. So your mother will undergo some series of process in order to produce half number of egg, and your father will also do the same thing to produce sperm, which is also equals to haploid cells, and when they now fuse together, they will now form a diploid zygote. Let's go. In gametogenesis, we have spermatogenesis and we have oogenesis. So spermatogenesis is from the male and oogenesis is from the female. So what is the difference between spermatogenesis and oogenesis? Is spermatogenesis is male and oogenesis is female. We are coming to that. First, let's start with gametogenesis and spermatogenesis. First, you have to have in mind is spermatogenesis occurs in the testes. So which region in the testes? The seminiferous tubule. Gametogenesis occurs in the seminiferous tubule of the testes. And how many sperm do your father secrete, or the human being that gave birth to you secrete, is about 150 to 275 million of spermatozoa. Spermatozoa is your sperm. So when your mother and your father are busy enjoying themselves, during that process your father is secreting 150 to 275 million sperm. So for you to exist, you must have conquered millions of people in your life. So for you to exist is not a mistake. You are called on this earth for a purpose, and that is what you must achieve. So when your mother and your father are busy doing something in the night, your father is secreting 275 million sperm, while your mother on the other hand have already undergo astrasia. Your mother have already have 2 million sperm, and dis 2 million sperm now undergo death, cell death. Dat cell death we call it astrasia. Astrasia is when your mother oocyte is egg. When they start dying to about 400,000 during puberty. Ovulation now start taking place. So that is not our main business for now. Our main focus is spermatogenesis. Don't worry, this course is interesting. So far you have the good teacher. So let's move over. We have spermatogonia. Spermatogonia is stem cell. And where is spermatogonia coming from? Primordial germ cell. Let's talk about primordial germ cell. What are primordial germ cell? Primordial germ cell are already present. So during the process of spermatogenesis, they will now migrate to the gonad. What are the gonad? The gonad is where gametes are formed. What are the gonad? The testes. So which particular site is gonad where sperm are formed is the seminiferous tubule. So this gonad will now produce spermatogonium or spermatogonia. And spermatogonia are stem cells. Remember, we have discussed about stem cells. So what are stem cells? Stem cells are unspecialized cells that can undergo mitotic. Now when I say mitotic, I hope you know what I'm saying. That can undergo mitotic cell division in order to produce themselves, or to order to produce specialized cell that will now give rise to special function. Example of stem cell is your zygote. Your zygote will undergo mitotic cell division to produce embryoblast and trophoblast. So they are unspecialized. When they become specialized, this embryoblast will further go to the future to produce embryo, and this trophoblast will further go to the future to produce placenta. Make sure you start this video from playlist to playlist. Make sure you start from the beginning. You have a biased understanding. You have a better knowledge of what I'm saying. I've taught trophoblast and embryoblast. I've just do something there. So go back to the first video. You understand this better. So let's go there. We have from spermatogonia, we now undergo mitotic cell division. Mitotic means they have diploid. And what's happening? We are forming primary spermatocyte. So the process, this is MBBS question, so you have to take it home. What is the process by which we convert spermatogonium or spermatogonia to primary spermatocytes is called spermatocytes. Spermatocytes are the process, or is a process or series of process that involve mitotic cell division by which we convert spermatogonium to primary spermatocytes. So what happens in spermatogenesis? The first step is spermatogonium give rise to primary spermatocytes. But before they give rise to this primary spermatocyte, let me explain something. Spermatogonium will come, divide. We say they are stem cell, and when we talk about stem cell, they are unspecialized. They are not specialized to develop themselves back or to form a specialized cell. So what is going to happen? This spermatogonium you are seeing here will come and divide and form spermatogonia type A and spermatogonia type B. So what is happening? Spermatogonia type A, why is the same thing as spermatogonia? So spermatogonium or spermatogonia is the same thing as spermatogonia type A, which you can also keep on undergoing mitotic cell division to produce spermatogonium. So this type B is now what we now go and form primary spermatocyte. This process is our first mitotic cell division. Let me recap for exam purpose. Listen. Spermatogonium will differentiate. They are stem cells, so they can form themselves or they can form what? A specialized cell. Now, this spermatogonium, they will differentiate to form themselves. What are the themselves there? A. They form spermatogonia type A. and they also divide. And when they divide mitotically, they produce two daughter cells. So the other one they have produced is now the specialized cell we're talking about, which is spermatogonial type B. This spermatogonial type B will now perform a specific function. So what is this specific function? They will now produce the spermatozoa. Spermatozoa is sperm. Spermatozoa is sperm. Don't forget. So let's go about to our main future. So from the primary spermatocytes, we now undergo our first meiotic first division. Now I want you to take note of something. This process begins during the puberty age or during the puberty area, and puberty time is around 12 to 13 years. Some textbook will tell you 11 to 13, but based on my research it is 12 to 13. While women or females, oogenesis begins before birth. So before they give birth to females, they have already start producing oocytes, they have already start producing egg. While male, they will not start, they will only start during puberty around 12 to 13 years. Now during the adolescence or during the late puberty, which is around 15 to 16, you are about, this is the time you're expected to see your sperm, your first sperm. Your first sperm will come out before it starts becoming fluent. And when your first sperm come out, it is not expected to be that nutritious. So during your 16, 15, some maybe 14 is rare. 17, 18, 19, that is when you're expected to see your first sperm or your spermatozoa. And remember, when you are ejaculating, when you are busy doing something with a gear, you are ejaculating 150 to 270 to 275 millions of sperm. Some male can even ejaculate 500 millions of sperm. Hey, be careful, be careful. So this is your useful time and you have to make use of it properly. So let's go. Primary spermatocytes will undergo meiotic cell division. This is our first meiotic cell division. And remember, in meiotic cell division, what are we doing? We are converting 46 chromosomes to 23 chromosomes, and this process is meiotic and or meiosis. So primary spermatocyte is converted to secondary spermatocytes. Then from secondary spermatocyte, it will undergo another meiotic cell division. We call them the second meiotic cell division, and the second meiotic cell division is equals to mitotic cell division. Look at what I mean. From primary spermatocyte to secondary spermatocyte, what is happening is meiotic cell division, and we go from 46 chromosome to 23 chromosome. Now from secondary spermatocyte to spermatid or spermatids, we now have also what we call 23 chromosome. Why? Remember in my explanation earlier, I said that your first meiotic cell division will reduce the chromosome to 23, while the second meiotic cell division is to multiply. They're not going to reduce, they will maintain that the same 23 chromosome. Now we have our spermatid. So as another exam key question, they will ask you during the process by which you convert primary spermatocytes to spermatid is called what? So the process by which we convert primary spermatocytes to spermatid is called what? So drop that in the comment section below. So next we have spermatid. In the spermatid, make sure I want to see your response. Drop it in the comment section below. What is the process by which you convert primary spermatocyte to spermatid? Is a question for you. Just this is commonly asked question in MBBS. Drop it in the comment section below. I want to see the answer. Ngwa, let's go. I have from spermatid we convert spermatids to spermatozoa. So look at, we are converting our spermatid to spermatozoa. So this is our spermatid, this is our spermatozoa. Our spermatozoa is also called the sperm. So that process is called spermiogenesis. Spermiogenesis is the process by which you convert spermatid to spermatozoa. And during this process, the spermatids are like cells, normal cell, normal cell usually have cell. They now have a nucleus, they now have Golgi bodies, they now have centroids. And what is happening? The process by which spermiogenesis is occurring. Spermiogenesis, don't forget, spermiogenesis is the conversion of spermatids to spermatozoa. So during this process, what is happening? The Golgi body or the Golgi complex or the Golgi apparatus, they are all the same thing. What is happening? It will start forming the acrosome. The acrosome will go and dissolve the zona pellucida in the oocyte. Don't worry, we are coming to there. In the oocyte, during fertilization, I'll explain this better. Just remember that the Golgi complex form the acrosome, the nucleus form the head of the sperm. The sperm start shedding off during spermatogenesis. This fluid in the cytoplasm start shedding off in order to have this spermatozoa shape, while in oogenesis the fluid is retained. I'm constructing so you have a better knowledge. I'm constructing so that exam will not trick your brain. Let's go. So let's recap this process. From spermatogonium to primary spermatocyte, which is our first mitotic cell division. From primary spermatocyte to secondary spermatocyte, which is our first meiosis. Second meiosis is to convert secondary spermatocyte to spermatid. And I want you to go and drop the answer to this question. The process by which you convert primary spermatocyte to spermatid is called what? I want to see it in the comment section below. From there, we now convert spermatid to what? Spermatozoa. This process is called spermiogenesis. Let's go back to oogenesis. What is happening? This is where the main problem is. Oogenesis. Now, females, be careful. Be mindful when you are doing abortion. Be mindful when you are doing so many complex things with your life. Be mindful of your youth age. Avoid sex. Sex is not a good thing. Sex is only meant for married people. Avoid sex because you can keep on enjoying yourself for just 5 minutes and the boy will secrete 500 sperm to your body. What will now happen? You will go and do abortion, and when you do abortion, your cilia will become immobile, and when your cilia is immobile, what is happening? Your egg will not be able to take to the what? To the fallopian tube, and when your egg is not able to move to the fallopian tube by the cilia, what is now happening? It now lead to ectopic pregnancy. Your fallopian tube will rupture, and when your fallopian tube rupture, what happens? You will not be able to give birth. It will destroy, it will lead to bleeding. The baby is out of the uterine tube. It will damage your womb. Avoid sex. This is warning. I'm warning you now. He said my people lacks knowledge. That is why you are doing what you are doing. What happens? Where is this then? So location in the ovary. That is where oogenesis is taking place. Ovarian follicles. So output, what is it giving at? It's every 1 month. So when you are seeing your menstruation, a menstruation is blood that come out from the uterus through the cervix to the vagina. We call it menstruation. Why ovulation? This usually confuse students. We have ovulation and we have menstruation. They are two different things. Oh. Don't confuse. Ovulation is when the egg or the oocyte move from the ovary to the fallopian tube. That is ovulation. That is ovulation. Take note of that. Ovulation is when the egg or the oocyte move from the ovary to the fallopian tube is ovulation. While menstruation is the shedding off of the endometrium of the uterus. The shedding off, don't worry, you understand that very well during ovarian cycle. The shedding off of the endometrium in the uterus is what we call menstruation, and it occur every month. It might occur from 2 days to 3 days to 5 days to 7 days. 7 days is actually abnormal, but the normal should occur 2 days or 5 days for normal females. You'll be menstruating. So let's go back to our main topic of the day, which is oogenesis. We are not talking about ovarian cycle. That is ovarian cycle. Don't worry if you don't understand that. During our ovarian cycle, we cover everything. We add book. Our main aim is to carry book and open your brain and add it inside. Whether you don't want to learn it or what, you must understand it by fire by force. So let's start. In before oogenesis occurred, oogenesis have start occurring immediately. Female is a result of when eggs from the sperm meet eggs from the oocyte. They fuse together, they form female. Why? Whenever the man produce Y and they meet with X, we now form a male. So female already starts undergoing oogenesis immediately 10 weeks after fertilization. Fertilization is when the male meets the female egg, is fertilization. So after 10 weeks, is approximately 2 months and 2 weeks. What is happening? Oogenesis have already start occurring. So what is oogenesis? Let's go. Oogenesis is the process by which we convert ogonium to one specialized or one ovum in the presence of sperm. Now, I want to bring something to understanding. Oogenesis do not complete until sperm is introduced into your body. Until sperm is introduced into a female body. So before we go to that, let's start. Ogonium undergo mitotic cell division. So what are we producing? We are producing primary spermatocytes. And during this is what during what? Before birth. Now let me explain, let me bring something to your knowledge. As a female, you have 2 million oocytes. Oocytes is egg. You have 2 million oocytes. Okay, as a female, you have 2 million oocytes in your body. There's also called astrasia. 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 What is happening? Let's go. You have 2 million egg or oocytes in your body before birth. And these 2 million egg will start dying. After they have been produced, immediately they are giving birth to you, it will stop producing. So you now have 2 million egg. And this 2 million egg is now arrested in prophase 1. This is cell division. Just note that the oocyte is arrested in prophase 1. And what is happening? These cells start dying by a process known as what? Astrasia. So they ask, what is astrasia? Astrasia is when the egg of the female start dying, the oocyte start dying with time. So this 2 million egg will reduce to 400,000 egg. The 2 million egg will be destroyed by a process known as astrasia to 400,000 egg. And in this 400,000 egg, during puberty, which is around 12 years, what happens? It is now free from the prophase. So during immediately you enter your puberty, it will now move from primary oocyte to your secondary oocyte. So when we move from our primary oocyte to our secondary oocyte, something happened. From our primary oocyte to secondary oocyte, first something have already occurred. So in the process by which you convert ogonium to primary oocyte, what is happening? There's what we call polar body. Our first polar body is formed. So this is our first polar body. Our first polar body is formed. This is our first polar body. They are smaller. So why are we forming this polar body? So what's the difference between primary oocytes and a polar body? So ogonium undergo mitotic cell division to form primary oocytes and a polar body. So a polar body is a cell that do not have much cytoplasms. Their cytoplasm is so small. So the main reason why your body is forming this polar body is in order to convert this diploid cell to haploid cell. Remember, the main reason why you are forming this polar body na to convert this diploid cell to haploid cell. Remember, diploid cell have 46 chromosome, and this 46 chromosome cannot join together with the sperm. So what will happen is this 46 chromosome will be reduced to primary oocyte and a polar body, and this polar body now contains the 23 chromosome, and the primary oocyte now contains the 23 chromosome, making it balanced. And when it now contains this 23 chromosome, what will now happen? It will now undergo meiotic cell division. It will now undergo meiotic cell division to form our second polar body. And in this polar body, don't confuse this. This is actually the exam question. Let me recap. Don't confuse this. This primary oocyte will undergo our first meiotic division, and this meiotic division is immediately you reach your puberty, which is around 12 years old or 11 to 13 years old, depending on the kind of woman you are. So what is happening? This primary oocyte is now converted to secondary oocyte, and during this process we form our first polar body and our secondary oocyte. And when we form our first polar body and our secondary oocyte, our first polar body has cytoplasms, little amount of cytoplasms, which is not sufficient to feed the polar body. So our main reason why we are converting this to polar body and a secondary oocyte is because we want to reduce the chromosome from 46 to 23 chromosome, and as we reduce this, they can now fuse with the sperm to form 46 chromosome. And as we reduce this, we now form our secondary oocytes. Our secondary oocyte will now be seized or arrested in the metaphase. And as it's arrested in the metaphase, arrested in the metaphase, what is now happening? During the introduction of sperm, when sperm is now in your body, it will now complete meiotic cell division. So what I'm trying to say is, in males, their spermiogenesis or their spermatogenesis is complete, but in females their oogenesis is never complete. So as you keep on seeing your ovulation every year, every month, month by month, meaning that you have not allowed, since they have given birth to you, you have not allowed any egg to complete oogenesis, to complete this oogenesis. So you have not allowed anyone. So at least try to allow one this month. Just allow one this month, so you get pregnant, and allow one this month. Allow one this month. Allow one this month, so that it will be complete. So what I'm just trying to say is, your oogenesis is only complete whenever there is introduction of sperm. And what is happening in conversion of secondary oocyte to our ovum? That is where ovulation that takes place. So in secondary oocyte to our ovum, the process is not complete. So the only thing that will complete this process is whenever sperm is introduced. So ovulation will just occur, and ovulation is when oocyte is transferred from the ovary to the fallopian tube. That is ovulation. And when sperm does not come within 24 hours, the oocyte will die off. And what now? So ovulation, and during ovulation, what happens? During ovulation, there is a small shock. If you calm down, just calm down. Use this week and observe yourself. Or during your ovulation period, or during your menstruation period, just calm down and calculate yourself. During the process by which you are transferring, the oocyte from the ovary to the fallopian tube, you will feel this shock. You feel the shock. The shock is there. If you calm down and experience it, you will feel the shock. The shock is there. Just calm down. Okay, let's go there. From there, we now form our ovum. You only form a fertilized ovum. We call it a fertilized ovum. We now form our second polar body. A fertilized ovum is whenever there is sperm. So if you want one of your egg, if you want to pity your egg and miss it for the egg, you can allow sperm this month. There is nothing much. Just allow sperm this month, you see a fertilized egg. If you don't allow egg, you are actually killing thousands of egg. Every month your follicle stimulating hormone come and pick 15 oocytes. And what is happening? They will start forming these oocytes and start maturing these oocytes. So the one that mature enough will now be transferred from the ovary to the fallopian tube. That is what's called ovulation. So when you don't allow sperm to enter through you are killing your cells that your body is producing. So let's go over to the next. So let's compare, let's contradict, let's differentiate for exam, let's trash, let's gross, let's penetrate, and let's emphasize on the specific point, the difference between spermatozoa and oocytes. So first, spermatogonium or ogonium begins the process. What is happening? Ogonium will now be converted to primary spermatocyte, mitotic cell division. This will now yield to what? They will now yield to 4 spermatozoa. The end of spermatogenesis is to produce 4 spermatozoa with a haploid cell. Why the end of oogenesis? You don't have any end oh. Remember, you have not completed any cycle since they gave birth to you. So far you have not get pregnant in your life before. So the end of ogonium or the end of oogenesis is menstruation, unless there is sperm inside your body. And when there is sperm, that is when you have only complete your oogenesis. Your oogenesis have not been completing. Just allow one this month. So at the end of this oogenesis, you end up forming only one egg. It's only one oocyte that is produced, one fertilized, only one sperm is involved. That is when you are going to form one ovum or one fertilized matured ovum. Why in spermatocytosis, what is happening? We are forming 4 haploid sperm or spermatozoa. Let's go there, which I've already explained. spermatogenesis and oogenesis. Cytoplasm is divided equally. So in spermatogenesis, the cytoplasm is divided equally. In oogenesis, the cytoplasm is not divided equally. It is unequal because we are forming a polar body and an oocyte, which is secondary oocyte. So the polar body has little amount of cytoplasm. For this reason, the cytoplasm is not shared equally. So this results to four haploid spermatozoa. This results to only one female large oocyte egg. Only one oocyte egg is produced. And this one oocyte, I'm emphasizing this because this is exam question whenever sperm is introduced. When sperm is not introduced, the oocyte will die off and is secreted out of the fallopian tube. What next? The genetic housekeepers. To eliminate one half of the diploid chromosome set produced by meiotic division, leaving behind a haploid cell. So during meiotic cell division, we are trying to produce haploid cell that will fuse with the haploid sperm to form a zygote. So what's now happening? We now form a polar body. We form a cell called a polar body which does not have cytoplasm. It has only little amount of cytoplasms, and they will not be able to sustain this cell. What will now happen? They will now die off. They will die. So at the end of oogenesis, you only have two polar bodies. But in a case they can twist your brain and they say we form three polar body. You only see three polar body when the first polar body from the primary spermatocyte have divided to form two polar body from with another polar body you now have in your secondary spermatocytes. So don't confuse that. You only have two polar body at the end of fertilization. You only have two polar body. So the three polar body is only when the first polar body have divided in the first primary spermatocyte. So a polar body is a small haploid cell containing chromosome. They contain chromosome, the haploid chromosome, but very little amount of what? Cytoplasm. It is the cellular trash bag for extra sets of genes. They frequently die and degenerate by apoptosis. Apoptosis is what? Cell death. When your cell keep on dying, we call it what? Apoptosis. So meiotic errors in polar body formation can be an indicator of what? Malfunctioning of the zygote. So when your zygote is malfunctioning, it can lead to so many things. Let's go. Let's keep on contradicting. So what is the difference between oogenesis and spermiogenesis? So the first thing you have to take note is spermiogenesis continues throughout lifetime. Some people own might stop at 60 years old, or at 60 it will reduce. Maybe your father can be ejaculating 500 million sperm to your mother vagina. But when your father starts getting old, he will start ejaculating little amounts of spermatozoa. It can be 50 millions of sperm, it can be 100, but it is now reduced from 500 million. So oogenesis stop at menopause. So oogenesis stop at menopause, and menopause is from 45 to 55 years old. Oogenesis stop at menopause. Menopause, it begins before birth and stop at menopause, but spermatogenesis only begins at puberty and continues throughout the lifetime. So let's go to our table. Our table is the difference between spermatogenesis and oogenesis. First begins at puberty. Spermatogenesis begins at puberty. Oogenesis begins in the fetus, in the fertile life, begins inside the birth, before birth, begins inside the woman uterus. So it is continuous through the lifetime. It is arrested. It stop at menopause, and lifelong of production. It ends at menopause. And lastly, millions per day. So a man is able to secrete 500 million per day, while in oogenesis only one fertilized egg is what? Secreted. Is formed. Only one egg is ovulated per month. Only one egg is ovulated. Take note of that. So I think we are gradually going to the end of these lectures. So let's go to hormones. Some hormonal conditions. What are hormones doing? So we have hypothalamus, where hypothalamus is part of the brain. Like they are just brain, they are part of the brain. So what is hypothalamus doing? Hypothalamus are secreting gonadotropin releasing hormone. This gonadotropin releasing hormone will go and start stimulating Pituitary gland will now start stimulating follicle stimulating hormone, and this follicle stimulating hormone starts stimulating estrogen, and this will now result to production of testosterone and spermatogenesis. And estrogen together with follicle stimulating hormone start stimulating luteinizing hormone. So luteinizing hormone starts signaling the ovaries to start producing what? Ovulation and factors that stimulate oocyte follicle growth. So a shared command center of both pathways. Hypothalamus releases gonadotropin releasing hormone, gonadotropin releasing hormone, and pituitary gland respond by releasing follicle stimulating hormone and luteinizing hormone. This hormone targets the gonad to drive gamete development and maturation in specific ways. So what is fertilization? Fertilization is a process by which sperm joins the female oocyte by which they binds. But before fertilization, capacitation occur. Don't worry, during our fertilization, we're going to explain this. Just know in fertilization, the sperm binds together with the what? With the female oocyte. And acrosome reaction occurs, it now leads to what? Fusion. Acrosome reaction means the secretion of enzymes and proteases from the acrosome. This will now break that benzonal peninsula. We will understand this better in our fertilization class. The two pathways culminate in a single well-coordinated event. The union of two terminal differentiated haploid cells to create a single totipotent diploid cells is called a zygote. So a zygote is an example of totipotent cell because totipotent cells are cells or stem cells that can differentiate to form a specific cell and itself. Example, they can differentiate to form an embryoblast and trophoblast. Embryoblast will now form the embryo, while trophoblast will now form the placenta in the future. This restores the diploid chromosome number and marks the beginning of new and genetically unique individual. So when you are fusing sperm and egg together, it will now lead to the formation of new individual. So we are gradually coming to the end of our lectures. Our flashcard says gametogenesis means formation of gametes, which is sperm and egg. Spermatogenesis means form functional sperm. We produce four sperm, which are spermatozoa. Oogenesis means we produce one ova and two polar bodies. So meiosis, the mechanism that reduces the chromosome number from diploid to haploid. This creates genetic diversity. That is why you never look like someone exactly. You can look like someone, but there will be a difference in character. There is something that will be different from the parents that produce you. There will be something that will be different. This is what we call genetic diversity. Don't forget that. So let's go to our questions and answers. First, what is gametogenesis? Which we all know gametogenesis is the process by which male and female gametes are formed through meiosis. Why does spermatogenesis produce four sperm but oogenesis produce one ovum? The answer to this is cytoplasm is divided equally in spermatogenesis but unequally in oogenesis to preserve nutrients for the ovum. That is why spermatogenesis produce four sperm but oogenesis produce one ovum. At which stage is the primary oocyte arrested? At prophase 1 of meiosis. That is where the primary oocyte is arrested. So during puberty, they will now continue. Where does spermatogenesis occur? Spermatogenesis occurs in the seminiferous tubulus of the testis. And what is the function of the polar body? The function of the polar bodies is to reduce the diploid number of the oocytes to haploid number and they now degenerate. So this is all I have for you. Don't forget to like, subscribe and hit the notification bell for more videos like this on Sagacious Learners. If you understand gametogenesis, embryology become easier. So watch this video over and over again for you to understand everything you have to say. Goodbye, see you next time.